Hello viewers, welcome to our channel Career Prep. In this video, we'll solve a few problems on the topic combination. Permutation and combination forms an important portion in competitive exams like SSC, UPSC, railways, banking, etc. Since questions based on this topic are most frequently asked in competitive exams, it makes sense to understand the concept well. Questions on combination are dealt with in this video along with clear explanations to make you understand the topic easily. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. There are 3 rooms in a hotel. One single, one double, and one for 4 persons. How many ways are there to house 7 persons in these rooms? Here you are given 4 options and you have to find out which of these options is the correct one. So it's given that there are total of 7 persons and there are 3 rooms in a hotel, one single, one double and one for 4 persons. So now choose one person from the 7 persons for the single room and from the remaining 6 persons choose 2 for the double room and then the remaining 4 persons will be for the 4 persons room. So one person can be chosen from 7 persons in 7C1 ways and is multiplication. 2 persons can be chosen from 6 persons in 6C2 ways and is multiplication, and 4 persons can be chosen from 4 persons in 4C4 ways. Now 7C1 is nothing but 7. 6C2 can be written as 6 multiplied by 5 divided by 2 factorial. 4C4 is nothing but 1. Now on solving this, we get 7 multiplied by 15 multiplied by 1, which is 105. So there are 105 ways to house 7 persons in the 3 rooms in the hotel. So the correct answer is option A, 105. In how many ways can 6 balls be selected from 11 different balls if 2 particular balls are always selected? Here you are given 5 options and you have to find out which of these options is the correct one. Now it's given that there are 11 different balls and 6 balls have to be selected from these 11 balls. But it's also given that 2 particular balls are always selected. Now, out of these 6 balls, if 2 particular balls are always selected, then the number of balls that remain to be selected would be 4. And these 4 balls have to be selected from a total number of 9 balls. Now, this is because although the total number of balls is 11, because 2 particular balls are always selected, you can leave out those 2 particular balls. So 11 minus 2 is 9. So the remaining 4 balls have to be selected from those 9 balls. So the number of ways to select 4 balls from 9 balls is 9C 4 ways. Now you can find the value of 9C4 either using the formula method or the shortcut method. Let's look at the formula method first. So according to the formula, 9C4 is nothing but 9 factorial divided by 4 factorial multiplied by 9 minus 4 factorial, which is 5 factorial. Now 9 factorial can be written as 9 multiplied by 8 multiplied by 7 multiplied by 6 multiplied by 5 factorial, so that the 5 factorial in the numerator and the 5 factorial in the denominator can cancel out. And on solving this, we get 126 ways. Now let's look at the shortcut method. 9C4 can be written as 9 multiplied by 8 multiplied by 7 multiplied by 6 divided by 4 factorial. Now on solving this, we get 126 ways. So there are 126 ways in which 6 balls can be selected from 11 different balls if 2 particular balls are always selected. So the correct answer is option B, 126. A group consists of 4 men, 6 women and 5 children. In how many ways can 2 men, 3 women and 1 child be selected from the given group? Here you are given 5 options and you have to find out which of these options is the correct one. So here you have to select 2 men from 4 men and 3 women from 6 women and 1 child from 5 children. So 2 men can be selected from 5 men in 4C2 ways and is multiplication. 3 women can be selected from 6 women in 6C3 ways and is multiplication. 1 child can be selected from 5 children in 5C1 ways. Now we can find the value of 4C2 multiplied by 6C3 multiplied by 5C1 either using the formula method or using the shortcut method. Let's look at the formula method first. Now according to the formula, 4C2 is nothing but 4 factorial divided by 2 factorial multiplied by 4 minus 2 factorial, which is 2 factorial, multiplied by 6C3 is nothing but 6 factorial divided by 3 factorial multiplied by 6 minus 3 factorial, which is 3 factorial, multiplied by 5C1, which is nothing but 5 factorial divided by 1 factorial multiplied by 5 minus 1 factorial, which is 4 factorial. Now we know that 4 factorial is 24 and 2 factorial multiplied by 2 factorial is 2 multiplied by 2, which is 4, and 24 divided by 4 is 6, multiplied by, now 6 factorial can be written as 6 multiplied by 5 multiplied by 4 multiplied by 3 factorial, so that the 3 factorial in the numerator and the 3 factorial in the denominator gets cancelled out. The 6 in the numerator and the 6 in the denominator also gets cancelled out and we are left with 5 multiplied by 4, which is 20, multiplied by 5 factorial is 120, 4 factorial is 24. 120 divided by 24 is 5. So 6 multiplied by 20 multiplied by 5 is 600. Now let's look at the shortcut method. 4C2 multiplied by 6C3 multiplied by 5C1. Now 4C2 can be written as 4 multiplied by 3 divided by 2 factorial. 6C3 can be written as 6 multiplied by 5 multiplied by 4 divided by 3 factorial. 5C1 can be written as 5 divided by 1 factorial. Now we know that 2 factorial is 2 and on solving this we get 6. Here 3 factorial is 6 and on solving this we get 20. And 1 factorial is 1, so we get 5 here. So 6 multiplied by 20 multiplied by 5 is 600. So there are 600 ways in which 2 men, 3 women and 1 child can be selected from the given group. So the correct answer is option B, 600. There are 5 novels and 4 biographies. In how many ways can 4 novels and 2 biographies be arranged on a shelf? Here you are given 5 options and you have to find out which of these options is the correct one. So here, out of 5 novels and 4 biographies, first you have to select 4 novels and 2 biographies. Now, since here selection is being done, the concept of combination has to be used. Now, once the 4 novels and 2 biographies have been selected, we have to find out in how many ways these 6 books can be arranged on a shelf. Since here arrangement is being done, the concept of permutation has to be used. So to solve this problem, the concepts of both permutation and combination has to be used. Now first let's find out in how many ways 4 novels and 2 biographies can be selected out of 5 novels and 4 biographies. Now 4 novels can be selected out of 5 novels in 5C4 ways. 2 biographies can be selected out of 4 biographies in 4C2 ways. So the number of ways of selecting 4 novels and 2 biographies is 5C4 multiplied by 4C2. Now 5C4 can be written as 5 multiplied by 4 multiplied by 3 multiplied by 2 divided by 4 factorial. And 4C2 can be written as 4 multiplied by 3 divided by 2 factorial. Now 4 multiplied by 3 multiplied by 2 in the numerator and 4 factorial in the denominator gets cancelled out, and we are left with 5 here. Multiplied by, we know that 2 factorial is 2. So when you solve this, you get 6. So 5 multiplied by 6 is 30. Now, after selecting any 4 novels and 2 biographies, that is 6 books, in one of the 30 ways, they can be arranged on the shelf in 6 factorial ways. Now 6 factorial is nothing but 720. So the 6 books can be arranged on the shelf in 720 ways. So the total number of arrangements is equal to 30 multiplied by 720, which is 21,600. So there are 21,600 ways in which 4 novels and 2 biographies can be arranged on a shelf. So the correct answer is option B, 21,600. There are 5 red balls and 6 green balls in a box. In how many ways can 6 balls be picked such that there are at least 2 balls of each color? Here you are given 5 options and you have to find out which of these options is the correct one. So here 6 balls have to be picked such that there are at least 2 red balls and at least 2 green balls. Now at least means a minimum of. So at least 2 red balls means minimum of 2 red balls, and at least 2 green balls means a minimum of 2 green balls. So out of a selection of 6 balls, there has to be a minimum of 2 red balls and a minimum of 2 green balls. This can happen in the following ways. Either 2 red balls and 4 green balls can be selected, or 3 red balls and 3 green balls can be selected, or 4 red balls and 2 green balls can be selected. Now as you can see here, in each of these cases there are at least 2 red balls and 2 green balls. Now it's given that there are totally 5 red balls and 6 green balls in a box. Now in the first case, 2 red balls can be selected from 5 red balls in 5C2 ways and is multiplication, and 5 green balls can be selected from 6 green balls in 6C4 ways. Now 6C4 can be written as 6C6 minus 4, which is 2. So 6C4 is nothing but 6C2. So now we have 5C2 multiplied by 6C2. 5C2 can be written as 5 multiplied by 4 divided by 2 factorial. And 6C2 can be written as 6 multiplied by 5 divided by 2 factorial. We know that 2 factorial is 2. So on solving this, we get 10 multiplied by 15, which is 150. Now let's look at the second case. Now 3 red balls can be selected from 5 red balls in 5C3 ways, and 3 green balls can be selected from 6 green balls in 6C3 ways. Now 5C3 can be written as 5C 5 minus 3, which is 2. So 5C3 is nothing but 5C2. So now we have 5C2 multiplied by 6C3. 5C2 is nothing but 5 multiplied by 4 divided by 2 factorial. And 6C3 can be written as 6 multiplied by 5 multiplied by 4 divided by 3 factorial. Now we know that 2 factorial is 2 and 3 factorial is 6. And on solving this, we get 10 multiplied by 20, which is 200. Now in the third case, 4 red balls can be selected from 5 red balls in 5C4 ways, and 2 green balls can be selected from 6 green balls in 6C2 ways. Now 5C4 can be written as 5C 5 minus 4, which is 1. So 5C4 is nothing but 5C1. So now we have 5C1 multiplied by 6C2. 5C1 is nothing but 5, and 6C2 can be written as 6 multiplied by 5 divided by 2 factorial. We know that 2 factorial is 2, and on solving this we get 15. So now we have 5 multiplied by 15, which is 75. So the total number of ways of picking 6 balls so that there are at least 2 red and at least 2 green balls is 150 plus 200 plus 75, which is 425. So 6 balls can be picked such that there are at least 2 balls of each color in 425 ways. So the correct answer is option D, 425. How many lines can you draw using 3 non-collinear points A, B and C on a plane? Here you are given 5 options and you have to find out which of these options is the correct one. Now first let's understand the meaning of collinear points and non-collinear points. Collinear points are points that are in a single line like this. And non-collinear points are points which are not in a single line. So one point can be here, one point can be here, and the other point can be here. So these are collinear points which are on a single line, and these are non-collinear points which are not on a single line. Now here in this problem we are asked to find how many lines can be drawn using 3 non-collinear points A, B and C. Now we know that 2 points are needed to draw a line. So 2 points have to be selected from the given 3 non-collinear points. So number of lines is equal to 3C2. 3C2 can be written as 3 multiplied by 2 divided by 2 factorial. Now 2 factorial is 2. So the 2 in the numerator and 2 in the denominator gets cancelled out. So the number of lines is 3. So 3 lines can be drawn using 3 non-collinear points A, B and C. So the correct answer is option A, 3. 6 points are marked on a straight line and 5 points are marked on another line which is parallel to the first one. How many straight lines, including the first 2, can be formed with these points? Here you are given 5 options and you have to find out which of these options is the correct one. Now it's given that there are 6 points on the first line and there are 5 points on the second line. Now we know that 2 points are needed to draw a line. Now excluding these 2 lines, to form new lines we need 1 point each from each of these lines. So 1 point can be selected from the 6 points in the first line in 6C1 ways and is multiplication, and 1 point can be selected from the 5 points on the second line in 5C1 ways. So number of lines is equal to 6C1 multiplied by 5C1. Now 6C1 is nothing but 6 and 5C1 is nothing but 5. So number of lines is equal to 6 multiplied by 5, which is 30. But earlier we had 2 lines. So the total number of lines including the 2 old lines is equal to 30 plus 2, which is 32. So 32 straight lines including the first 2 can be formed with the given points. So the correct answer is option E, 32. There are 7 non-collinear points. How many triangles can be drawn by joining these points? You are given 5 options here and you have to find out which of these options is the correct one. Now you know that a triangle is formed by joining any 3 non-collinear points. Now it's given that there are 7 non-collinear points. So 3 non-collinear points have to be selected from these 7 non-collinear points. 3 non-collinear points can be selected from 7 non-collinear points in 7C3 ways. So the number of triangles formed is equal to 7C3, which is nothing but 7 multiplied by 6 multiplied by 5 divided by 3 factorial. We know that 3 factorial is 6. So the 6 in the numerator and the 6 in the denominator gets cancelled. 7 multiplied by 5 is 35. So 35 triangles can be drawn by joining the given 7 non-collinear points. So the correct answer is option C, 35. 12 points lie on a circle. How many cyclic quadrilaterals can be drawn by using these points? Here you are given 5 options and you have to find out which of these options is the correct one. First, let's understand what is a cyclic quadrilateral. Now you know that a quadrilateral is a four-sided closed figure. Now a cyclic quadrilateral is a quadrilateral which has all its 4 vertices lying on a circle, lying on the circumference of a circle. Now as you can see here, this is a cyclic quadrilateral because all the 4 vertices of the quadrilateral lie on the circumference of the circle. Now this is not a cyclic quadrilateral because this vertex of the quadrilateral does not lie on the circumference of the circle. So here for any set of 4 points lying on the circumference of a circle, we get a cyclic quadrilateral. Now it's given that there are 12 points lying on a circle. So we have to select 4 points from these 12 points. Now the number of ways of choosing 4 points out of 12 points is given by 12C4. Now 12C4 is nothing but 12 multiplied by 11 multiplied by 10 multiplied by 9 divided by 4 factorial. 4 factorial is 4 multiplied by 3 multiplied by 2 multiplied by 1. Now on solving this we get 495. So we can draw 495 cyclic quadrilaterals from the given 12 points which lie on the circumference of the circle. So the correct answer is option C, 495. How many parallelograms will be formed if 7 parallel horizontal lines intersect 6 parallel vertical lines? Here you are given 5 options and you have to find out which of these options is the correct one. Now as you can see in this parallelogram, this pair of parallel lines intersects this pair of parallel lines to form the parallelogram. Also note that this pair of parallel lines is not parallel to this pair of parallel lines. So parallelograms are formed when any 2 pairs of parallel lines intersect and each pair is not parallel to the other pair. So in this question it's given that 7 parallel horizontal lines intersects 6 parallel vertical lines. So now we have to select one pair of parallel lines from 7 parallel horizontal lines, and one pair of parallel lines has to be selected from 6 parallel vertical lines. Now we know that a pair means 2. So 2 parallel lines have to be selected from 7 parallel horizontal lines, and 2 parallel lines have to be selected from 6 parallel vertical lines. Now 2 lines can be selected from 7 parallel horizontal lines in 7C2 ways, and 2 lines can be selected from 6 parallel vertical lines in 6C2 ways. So the total number of parallelograms formed is equal to 7C2 multiplied by 6C2. 7C2 is nothing but 7 multiplied by 6 divided by 2 factorial, and is multiplication. 6C2 means 6 multiplied by 5 divided by 2 factorial. We know that 2 factorial is 2. So on solving this, we get 21 multiplied by 15, which is 315. So 315 parallelograms will be formed if 5 parallel horizontal lines intersect 6 parallel vertical lines. So the correct answer is option B, 315. Find the number of diagonals in a regular octagon. Here you are given 5 options and you have to find out which of these options is the correct one. Now as you can see in this octagon, there are 8 sides. Also there are 8 vertices. So a regular octagon has 8 vertices. Now you know that a line can be drawn between any two vertices. So two vertices has to be selected from 8 vertices, and this can be done in 8C2 ways. So number of lines that can be drawn is given by 8C2, which is nothing but 8 multiplied by 7 divided by 2 factorial. 2 factorial is 2, and on solving this we get 28 lines. Now, of these 28 lines, 8 lines are actually the sides of the octagon and the rest are the diagonals. So, the required answer is 28 minus 8, which is 20. So, 20 diagonals can be drawn in a regular octagon. So, the correct answer is option C, 20. There are 30 people in a group. If all shake hands with one another, how many handshakes are possible? Here you are given 5 options and you have to find out which of these options is the correct one. So it's given that there are 30 people in a group and all shake hands with one another. Now you know that 2 people are required for a handshake. So 2 people have to be selected from the 30 people, and this can be done in 30C2 ways. So total number of handshakes is given by 30C2, which is nothing but 30 multiplied by 29 divided by 2 factorial. 2 factorial is 2, and on solving this we get 435. So 435 handshakes are possible in a group of 30 people where all shake hands with one another. So the correct answer is option B, 435. Viewers, please go through this video till you have understood the concept. Please do watch all our videos on solved problems and combinations for better understanding. Please do watch a video on circular permutations. If you have liked this video, please like, subscribe and share this video. Thank you.